Most code written during your studies stays hidden in a private directory. To demonstrate your capability to a hiring manager, you need to move that code out of the shadows and into a transparent, professional portfolio. With the rise of AI-driven productivity, traditional degrees are losing their impact. Professional teams now prioritize candidates who provide proof of work, functional applications built using industry-standard engineering workflows. To build this proof, you need a few prerequisites: Git installed locally, your global username and email configured, a GitHub account, and a basic Python script saved in a project folder. Following this specific command sequence is the standard method for transitioning your local experiments into the public tech ecosystem. We start by transforming your standard folder into a tracked repository. Open your terminal within the project directory and type git init. This creates the background infrastructure Git uses to monitor your files. Get into the habit of typing git status. This is your diagnostic tool. Right now, it will list your Python script in red, indicating that the file is currently untracked and outside of Git's version control. To track the script, we move it into a draft space called the staging area. In your terminal, type git add, followed by the name of your file. Check your status again. The file name has turned green, confirming that Git is now tracking your changes, and the file is ready to be saved to your project's timeline. Type git commit-m, followed by a concise description of your work in quotes. This creates a permanent snapshot of your code within your local repository. Every commit records a specific moment in your project's history. This workflow creates a durable timeline where every modification is documented and every previous version is recoverable. Professional developers rarely edit a stable, working codebase directly. Instead, they use a safety mechanism called a feature branch to isolate new experiments and updates. Create your isolated sandbox by typing git branch and a feature name. Then switch into it by typing git checkout followed by that same name. Your terminal prompt will now display your new branch name. This confirms your workspace is independent, allowing you to modify your code without affecting the main timeline. If you edit your script and commit the changes now, the update exists only on this independent feature path. As this diagram shows, your main timeline remains unchanged and production ready. To integrate your completed work, you must first switch back to the receiving timeline. Type get checkout main to return to your primary branch. Now run the command git merge followed by the name of your feature branch. Git pulls the completed work from the isolated branch back into the main codebase. This isolation is why branching is a core industry practice. It ensures your project remains stable while you solve specific technical problems. Your project is now secured locally, but it's still invisible to the world. We need to upload this timeline to GitHub to make it a public asset. Log into your GitHub account and create a new empty repository. Once it's created, copy the remote locator link provided on the setup page. In your terminal, type git remote add origin and paste your link. This tells your local Git exactly where to send your data in the cloud. To perform the upload, type git push-u origin main. This command sends your entire local project history to the GitHub cloud. The terminal output will show a progress percentage. Once it reaches 100%, your remote tracking is established and your work is live. Your local workstation and the GitHub cloud are now synchronized. This completes the bridge between your private workspace and the global developer community. Refresh your browser on the GitHub repository page. You will see your Python file, your branch structure, and your complete commit history successfully replicated online. This repository is now a functional part of your portfolio. Hiring managers can analyze your code structure and commit history to verify exactly how you approach engineering tasks. To reinforce this workflow, immediately try creating a second feature branch, modifying your script, and pushing those new updates live to GitHub. By adopting this collaboration architecture, you are following the same standards as the world's most successful open source projects, transitioning from a student to an active builder.